Welcome to Agents of Change, conversations with the people shaping sustainable manufacturing. This podcast is a virtual hero media production for the MANSUS platform. Hello and welcome. I'm Gemma, your host, and today I have the great pleasure of being joined by Sofia Peruzzo, Group ESG Manager at SK TES, a global leader in IT asset disposition, e-waste management and battery recycling solutions. Let's get straight into the conversation.
So I started my career actually in the research sector, and I was looking at the connection between environmental impact and, let's say, ecosystem degradation, and what would be the impact on the local communities, especially in developing countries. And then at one point, I had the opportunity to join a company that is aligned with this kind of practices and principle, such as reducing the environmental impact, but also the impacts on society overall. And so this brought me to my position at SK TES. So SK TES is involved in the commissioning of end-of-life IT devices and batteries. So mostly, let's say, giving a second life to these devices or recovering the materials when there's no useful life left. And my role at SK TES is ESG Manager. So I'm involved in overseeing sustainability, reporting, and sustainability practices as initiatives. So, for example, emissions reduction initiatives or social responsibility initiatives, but also support and work with clients to see what we can do and how we can support the clients in reducing their environmental impact through circular economy practices, for example, reducing emissions or resource use and so on. And also support them in complying with sustainability regulations that are coming up everywhere lately.
Yeah, and we've talked previously, Sophia, and you've mentioned that recycling really begins at the design phase. So what steps or principles then should manufacturers prioritise to ensure that they are designing recyclable products? And what do they need to think about in terms of materials?
So I think the really overall approach is to look at the whole life cycle of the product, right? So when you start looking at the different phases that come after the production, you have, for example, when you look at the use, you will think about durability and longevity, or when you think about the end of the first life, you will think about repairability. And what we talk about now is when you look at the end of life, you want to maximize also for recyclability. So there's different ways in that we can do that. One initial aspect can be really the design itself. So modularity is one key concept. So really making the product that you're producing in a way that is easy to disassemble, that will support really the recyclability at the end of life. It will make it not just easier for recyclers to separate those materials and those components, but we really increase the chances of recover the materials. So we'll probably allow a higher recovery rate of materials when there's a high modularity. And connected with this topic also, what we see a lot in the electronic industries and in the battery industries is a high use of adhesive. So use of, for example, glues and similar products. And this can really also impact the recyclability of the product at the end of life. So minimize these types of chemicals or parts. It can really help the recyclers to separate those components without the need of maybe shredding all together at the end of let's say for recycling, and this could also pose a risk in terms of having mixes of recyclable and non-recyclable materials and make it really hard then to recover those materials that can be recovered. So there's different alternative joining methods that can be used, for example, to replace additive and to increase modularity. So, for example, when we look at mechanical fasteners, such as screws and so on, or other types of designs that like snap fit designs. And then it really depends on the sector and the type of products that you're producing. And another point connected with modularity is also and recyclability is also the separation of materials within the components. So we looked at how it would be ideal to be able to separate those components as easily as possible, but also within the components, the more types of material are used, the more difficult will be then to recover each one of those materials. So then it really depends on what kind of product you're creating, right? And what is possible in terms of functionality. But ideally, when it's possible, it would be really good for recyclability to decrease the amount of single material for each component, and having those separate material in separate components. And this would again maximize the recovery rate at the end of life. Another crucial point, as you mentioned, is the choice of materials, right? Because the materials to be able to recycle at the end of life, it needs to be a recyclable materials. So there's different types of materials. For example, when we look at the electronics and battery industry, where I come from, there the most used materials are plastics and metals. So those are materials that are used in many other sectors as well, right? So not just these specific industries. And when you look at this type of materials, there's a large variability, and there's some that are recyclable and some that are not. So, for example, when we look at metals, we have many metals that are actually recyclable, and there's been a lot of progress on these points in the industry and in the metal industry overall. There are some metals such as aluminum and steel where the recycling technology is very well established. And there are other metals where perhaps like gold or precious metals or rare earth metals, these are also recoverable, even though they need a bit of more, let's say, energy intense process. And then you have those metals such as toxic metals that make it very hard to recover. So this is definitely something to think about when producing a new product. So toxic substances overall will need a different type of setup and health and safety setup at the recycler side. And so this will also increase probably the cost overall, but also sometimes we have regulations that actually don't allow those toxic materials to be recovered. So in certain legislation, those toxic material needs to go to landfill by law. So it really doesn't leave any space for recycler to be able to recover those materials. And it's similar also for plastics. So there are different type of plastics, and plastic is used in a lot of industries as well. There's some plastic that work well with heat. So for example, they soften with heat, and then they are more rigid when they're cooled. And then there's some other types of plastics that becomes rigid with heat and also remain rigid with cooling. So these last types of plastics are very hard to recover.
Yeah.
So this characteristic of the plastic is also something that can be taken into account when deciding what material to use. And when we look at plastics, it's not just the material itself, but there's also some additives that are used that make it also more difficult to recover the material and the product at the end of life. For example, we see also outside of the electronic industry, we see, for example, plasticizers, which are used to soften the plastic, but makes it very hard for recyclers then to recover those materials. Or, for example, colored plastic, right? Which is maybe very appealing for consumers, but it makes it also harder then to recover the plastic. And there are also some chemicals, for example, that are added, such as an example is the brominated flame retardants, that is basically chemicals to make a product less flammable. But this will make the product or dust material also, again, a toxic material because it has some impact on health, on human health. Yeah, so this will also something to take into account, let's say, that it connects again with the toxic material mentioned earlier. And so that said, in theory, that's what we want to achieve is having recyclable and not toxic material, right? But then in practices, of course, there are some challenges because
Yeah.
we know that when you want to maximize for recyclability, for example, maybe you need to sacrifice some of the qualities, such as might be durability or might be the desirability for the consumer or might even be cost, right? So I think the producer will have to do their own analysis and having their understanding on what are the trade-offs and finding that balance really on what they want to maximize for. And maybe one last point is also regulation and the role that regulations are playing on this topic. We see at the end of life, there's a lot of regulations coming up and already established on extended producer responsibility. So this is basically the responsibility is shifted on the producers to collect those end-of-life products and to manage them, so to handle the end of life, the recycling, and so on. And so this will put the cost of the recycling also on the producers. So designing the product with the recyclability in mind might have also some cost benefits for the for the producer himself. So also something to take
Yeah.
into account.
Yeah, and with that last piece there about the regulation, it sort of comes full circle in my mind, because as you were talking about the ways that manufacturers can design these products to be more recyclable, I was thinking, wow, this is complex, because there's lots of consequences. As you say, you know, it could affect durability, or so
Yep,
I'm thinking, gosh, this is quite a complex piece. And there's lots, and as you say, it's going to be different from manufacturer to manufacturer, depending on the product, depending on the unique
definitely.
circumstances
Hmm.
of their product. So what I was thinking is, as you were talking, how engaged are these electronic companies then in designing for recyclability? But it's the piece at the end about regulation, and that's where it comes full circle. Well, actually, as the producer, as the manufacturer, if you're also responsible for managing that product at the end of its life, of course it makes sense then, doesn't it, to start to make that
Yes.
shift to design the products to be more environmentally or to be more recyclable in the first place.
Definitely. Yeah, and we've seen it a lot in the electronic industry. There's more and more manufacturers that are really designing those products, thinking about the end of life, and that are engaging with recyclers. I was at a conference on end of life of electronics, and they were there also to present and to listen. They were there, the producers, the bigger producer of electronics, and so it's really great to see these two part of the value chain of the same products coming together to see how we can solve challenges on both sides. Yeah.
Yeah, that dialogue is essential, isn't it?
Yeah.
So, how do the environmental, social, and supply chain impacts of recycling compare then to using raw materials? And can you share some data or examples around that?
Sure. So we looked at what are the challenges in using materials that are recyclable, right, at end of life, and also using materials that come from recycling, so what we can call secondary materials, also doesn't come without any challenges. So probably in some industries and some material types, there's still some work to do to achieve the same quality for the secondary material compared to that virgin material, right? But that said, I think there's a lot of progress being done in some types of material. For example, for metals, for as of now, it's possible for many metals to achieve a big quality um, compared to the virgin material. And so I think there's a lot of progress going on, and this is very promising. And so there's a lot of benefits, as you mentioned, in actually using those type of secondary materials under the environmental side, under the social aspects, and also economic benefits. So if we look at them one by one, in terms of when we look at the environmental impact and environmental overall, the mining sectors is we know that is associated with activities that are quite disruptive for the environment. So it can lead to significant environmental degradation, for example, or habitat loss and biodiversity loss. And also there's a high usage of water in the mining sectors. And it's also a sector that is quite energy intensive and emission intensive. So we looked at we've done some research on what is the difference in impact in using primary materials compared to secondary materials, especially in terms of what are the emissions that are generated in comparison. And I have some example here then on materials that come from the electronic industry, but you will see it a lot in many other industries as well. So when we look, for example, at one of the most astonishing one that I have here is, for example, gold. So when you want to produce 1 kilogram of gold from virgin material, you will produce around 41,000 kilograms of CO2 emissions in equivalents. So around 41 tons. So this is a lot for only 1 kilogram of gold. And when you look at the secondary material, you can reduce it down to 1.5 tons. So it's really almost 30 times lower, right? So this gold and the precious metals are the ones that are very high impact. Also, when we look at the recycling side, 1.5 tons is very high compared to many others because it's a very energy intensive process. So I want to give an example also of a more of a lower impact metal, and that is used in a lot of industries, for example, aluminum. So to produce 1 kilogram of aluminum, you will need to emit 15 kilograms of CO2 emissions, so significantly lower when we talk about the primary material. But again, when we compare it with the secondary material, we only have a zero point 0.8 kilograms of emissions that are generated, and these are averages. So there might be slight differences when you look at different types of processes or different types of or different regions. But let's say you always have this very high difference between primary and secondary. And maybe I can give one more example on the plastics. When we look at one type of plastic that is recyclable, which is polycarbonate, you have about 6 kilograms to produce the plastic, so doing the extraction, the production of the primary plastic. And then you can reduce it down to zero point 0.2 kilograms of emissions to produce 1 kilogram of secondary material. So
Right.
you can see really the difference between the secondary and the primary material. And then this reflects on the products, because really the embodied emissions of the product are not just the manufacturing itself, but a large part of it is the acquisition of the raw material. So choosing the material and choosing to use a secondary material can really bring down these environmental or these emissions generated from the production or from the embodied emissions. And then, as you mentioned, also we have some social benefits. So we know that the mining sector is usually um, doing activities in countries such as developing countries that have usually lower regulation oversight, right? So regulations are maybe not as strict. And so sometimes we come across artisanal mining, for example, where there are practices such as forced labor or child labor that are really human rights violation. And sometimes the health and safety of the workers and the communities can also be at risk and can be impacted. So when we look at the recycling sector overall, usually takes place in countries where there's more regulations and more attention to this kind of labor practices. And also usually there are regulations around health and safety as well, both for the people and also for, let's say, environmental protection. But also, let's say the recycling industry doesn't come without challenges. There's also a part that is called the informal sector, which is also less regulated and comes with some environmental and social concern. But we can say that overall, it's lower than what the mining sector is. And I think there is more of an effort to try to regulate those kind of practices as well.
Yeah.
And then to conclude, we talked about a supply chain risk as well, right? So there can be economic benefits in using secondary material as well, in terms of mitigating this type of supply chain risk. Because when you use primary material, you might have fluctuation of price, for example. You might have geopolitical tensions, especially for some specific types of material. And you might have also some risk of some monopolistic supply chain. For example, in the electronic industry, what is used a lot is rare earth metals, and for now are not possible to be replaced, are very important metals in this industry. And 99% of these type of metals comes from one country, which is China. So you can imagine what are then the risks in terms of supply chain. And then, so using secondary material can really help having a more predictable source, a more diversified source, and perhaps also lowering the cost sometimes.
what are the opportunities in terms of closed loop solution in terms of the electronics industry then?
So we've seen more and more closed loop solutions coming up, especially in those batteries that are within the electronics. And I think this has been also pushed a lot by regulation. So we have the EU, European battery regulation that is coming up, and this requires some content, some percentage of recycled content in there. And it has been very good to see how then there has been a lot of research and development to see how you can actually extract those materials, for example, metals, such as cobalt, lithium, and so on, and achieving a similar quality of the material that goes back into the batteries. So this doesn't come without challenges, as I was mentioning earlier. I think it has taken a few years, and probably regulations can play a similar role in different types of products as well, to establish those type of closed loop solutions. But ideally, it's possible for many metals, and metals are used in so many applications, that it's very promising. Plastic might be a bit more challenging. Also, plastics are a very low value product or material, so there's also less willingness for businesses to put up a business that can recycle plastic. But not just willingness, it's harder to establish such a business model. So I think there again there should be such incentive from regulations again. Yeah.
Yeah. So, traceability and transparency are big issues today. How does the concept of a digital product passport support manufacturers in measuring and managing environmental impact? And what role might it play in the future then?
So the Digital Product Passport is a very interesting initiative that is coming up as part of European regulation again, which is the eco design for sustainable products. But the concept can really be applied also outside of the regulation. And the idea is that a tool that, as you mentioned, promises high transparency and high traceability across the supply chain of a product. So it's basically a digital record that will have inside a lot of information, useful information for manufacturers and for all the players along the value chain. So, for example, types of information you might have is what is the origin of the materials that are coming from the suppliers. What is the environmental impact of producing those materials in terms of, for example, emission generation or in terms of energy and water used? And you will also have not just this origin and these informations on environmental impact, but also the types of material that are included and how it's possible to recycle. So potential for example, recyclability or manufacturing, and also those substances of concerns that we talked about earlier and how to handle them. So it is a big opportunities actually for many players, as we said, for manufacturers, for example, they will really be able to track the origin of those materials, and that up to all the tiers of the suppliers, right? So up to the first supplier, and they will be able to identify what are the high impact areas within their supply chain and within the supply chain of their products. And so when you have availability of this data and when you have an understanding where is your high impact area, you can really decide how to act, and you have an opportunity to make a decision to lower the impact of your product. So producers might decide to, for example, change supplier to a more environmentally sound supplier, or they might decide also to redesign products, for example, avoid some resource or some types of materials that come with the challenges. Another information that is in the digital product passport will be the compliance with regulations. So I think this will also be another opportunity for manufacturer, for example, to reduce litigation risks. And in terms of regulations, also there's a lot of regulations, sustainability regulations coming up that will also mandate the suppliers to report on scope 3 emissions.
Mm.
So this will also allow the manufacturers to um, comply with this type of regulations and to more easily and more accurately collect those kind of information on scope 3 emissions, which are basically the emissions that occur along the value chain, right? So including the supply chain. And in terms of the role that this tool can play in the future, I think it will be not only beneficial for producers, but also for the consumers, because they will
Yeah,
have access to a lot more information, a lot of transparency of this information of their upstream activities and impacts. And so the consumers will really be able to make informed decisions and will also be able to steer let's say, the market potentially to really push for those more sustainable products. And will also help, I think, authorities in checking the compliance of the producers and all the upstream suppliers with their sustainability regulations that are coming up.
yeah,
And it's interesting to see how the digital product passport will apply to more and more products coming up in the European regulation. So the EU has this roadmap by 2030, and they want to include more than 30 products. So they are starting with batteries and others in the very near futures, and then they will include more and more, such as electronics, textile products, or construction materials. So really will touch on so much that we interact with every day. So it will be interesting to see how this will play out. And I think this will bring benefits for recyclers as well, because it will probably enable better recyclability thanks to this information of what are the type of materials and the best practices for recover those.
if there's one major change that you want to champion in the manufacturing sector, Sophia, to make a global impact, what would that be?
So I think there would be a big opportunity for including next to the ownership approach or ownership model to enhance also the offering of a sharing model. So what we can call also the sharing economy, which also include more collaborations with players along the value chain, such as repair, refurbishing, and recycling partners. So the idea here is that you would have this sharing economy model on products that are probably higher in cost or that are probably less frequently used. And it would allow the consumers to not need to do this one-time purchase of a product, but they could access the product as they need and paying only for the use. And at the
Yeah,
same time, it would allow also the manufacturer to retain the ownership of this product and to really control the whole life cycle of the product. So I think this on one side would incentivize really the manufacturer of designing for durability, designing for repairability and recyclability, because they will have an interest and this will play a role also in their profitability. I think that in this sharing economy, there should be some guidelines also in terms of the use for the consumers. What are the best practices of using these products for maximizing, for example, for recyclability or sorry, for durability, for longevity of the product, and this will have really an impact on both sides, on the producers, but also it will allow the consumers to empower themselves if they're willing to, and to also play a role, in the circular economy and really not just the corporate sector. And I think also that this sharing model, to be successful, will also need to include those players such as repair, refurbish, and recycling partners, because they would also play a significant role in allow those materials and those products to stay in circulation for as long as possible, right? So to stay, to be the products to be used for as long as possible, and then to effectively recover the materials. And really, this model would benefit all the parties involved because you have the users that would be only paying for the one-time use or for when they need, and they might also be able to access some products that otherwise they wouldn't decide to purchase or they couldn't afford it maybe. And then there are benefits for manufacturer as well, because they can establish this recurrent revenue stream, and they can access new customer segments. And then they can also really have, as we said, this control over the whole product and also the materials that are in there and the parts, and then they can recover those for reuse. And also then would benefits the end of life players such as the recyclers, the refurbishers, because they can also establish this stable business with a consistent supply chain, let's say. So, and I think this could be applied, this type of model, which we can call like product as a service model, would really apply to many different industries. And as I said, it would benefit many types of parties involved, but also would benefit this advancement towards a more circular economy. So it would help the environmental protection and the protection of the communities and the people, which is what we're also talking about.
Well, that brings us to the end of our conversation, Sofia. It's been really insightful.
Yes, thanks. Thanks for having me. It was great.
Thanks,
Thank you.
Sofia. Thanks for listening to Agents of Change, a virtual Hero Media production for the MANSUS platform. You can explore more at mansus.co, subscribe to our YouTube channel to stay up to date with every episode, and follow us on LinkedIn to join the conversation.